We've seen how de Moivre's theorem enables us to prove some fancy identities about trig functions. But if you've done some practice with this already, you may have come across these really long, messy expressions when using the binomial expansion and found that they take ages to write out and it's easy to make a mistake. So I'm just going to give you some tips here as to how to lay them out nicely. I'm going to get rid of that and start again. We have, by de Moivre's theorem, that cos of 8 theta plus I sine of 8 theta equals cos theta plus I sine theta to the power of 8. Now, first tip is to define C equals cos theta and S equals sine theta. This will just mean we don't need to write these out every single time. It will save us time and ink. Be careful if you do this, write at the top what you're defining them as, so whoever's marking this knows exactly what you're doing. Next tip, when you do the binomial expansion, write it vertically. I'll show you what I mean. So I'm going to start with the binomial coefficients. I've just done it, so I know what Pascal's triangle is for the 8th row. 1, 8, 28, 56, 70, 56, 28, 8, 1. Nicely laid out. I can see the symmetry. I've got all of those okay. Now I'll do the cos bits. We've got cos to the 8, cos to the 7, 6, 5, 4, 3, 2, 1, 0. Great, got all the cos bits. I've not made a mistake so far. Then I'm going to do the sine bits, I think separately to the I. Okay, so this one's going to have sine, sine squared, sine cubed, sine to the 4, sine to the 5, sine to the 6, sine to the 7, sine to the 8. Now, the i's have the same power as the sines going through this, but I'm going to simplify the i's as I go. So this one doesn't have an I in it. This one just has I. This one has I squared. But I know that I squared is -1, so I'm just going to whack that negative there. I cubed is negative I. I to the power of 4 is just 1 again, so it's not there. I have in my head here the repeating values that when we have I squared is -1, I cubed is -I to the power of 4 is 1, and then it cycles round. I have this image in my head when I'm doing it. So where did we get up to? We got up to -I, 1, I, -1, -I, and 1. Let's just fill in all those pluses. And we can see this pattern, positive, positive, negative, negative, positive, positive, negative, negative, positive again. And the i's are in alternate ones. Great. And by spotting those patterns, we can be sure not to make a mistake. Now, depending on what question you're asking, you're answering, we want either the real part or the imaginary part here. I'm going to suppose I want to prove an identity in cos, so I just want the real parts. And laying it out like this also makes it easy to pick out all the real parts. I get, then, that cos of 8 theta equals cos to the 8 minus 28 cos to the 6 sine squared. So I've got that. Cos to the 4 sine to the 4 minus 28 cos squared sine to the 6 plus sine to the 8. Great. And then I would write that out fully and underline it as my... When I say fully, I mean with the causes and signs in there now, and underline it as my final answer. But I'm not going to do that now for the benefit of a short video. Hopefully you've seen there how laying it out vertically enables us to spot patterns so we don't make any mistakes and is slightly quicker. Good luck with that.